Hello everyone, welcome back to MAC1105. In this video, I'm gonna show you how to solve a log equation. Log equation is the equation that contains logarithm, and it can contain one log or two log or many logs. Okay, and our goal is to combine all the log together, or we might use a log principle. Okay, or we can use the equivalence property. So in this video, I'm going to show you all the method of solving log equation. Okay, so let's get started. So I'm going to put over here log equation. Okay, log equation. Alright, and the first method of solving log equation is that we can use log property, log equivalence property. I'm sorry, equivalence property. Alright, so what is log equivalence property? The property said that if we have log base b of x equal log base b of y, you see that the base is the same, then it's imply x equal y. So how are we going to understand this property? It means that if we have two log, okay, and the base is the same, then we can set up the argument equal each other. Okay, and this property is very helpful. Believe me, it helps you to solve many log equation. I mean, the simple one, of course, the harder one we're going to use different way of solving equation. But this one will help you to solve a very simple log equation. For example, I have something like this. All right, what if I have log base 2 of x minus 5 equal log base 2 of 4x plus 1, for example. So I have, in this equation, you see that I have two log and the base is the same. So because the base is the same, I can imply the argument equal each other. Alright, the argument equal each other. So the argument here is x minus 5 equal to 4x plus 1. Okay, which is equal to what? Go ahead and solve this. This is very basically an equation give you negative 3x equal to 6. And x equal to negative 2. Okay, and we gotta go back in here and check it, and you see that x equal to negative 2, right? Negative 2, negative 5, negative 7, and there's no way. Over here is negative log base 2 of negative 7. Over here log base 2 is also of negative 7, right? Okay, but log base 2 of negative 7, can we go ahead and calculate them out? No, right? I mean because the argument over here, the argument must be greater than 5. Oh, okay, the argument must be greater than 5. So x must be greater than 5, and you see that our x is equal to negative 2. So of course, even though we got the x value, but this is not the solution. This is extraneous solution. Okay, so I mean the final conclusion for this equation would be no solution. Okay. Okay. See, very simple. How about this one? Let me give you the one that that you can solve for x, and that x is a solution. Let's see how about this one. I have log base 8 of x plus 2 equal to log base 8 of 2x minus 1. So this is imply x plus 2 equal to x minus 1. So I'll give you 3 equal to x. So x equal 3. Alright, let's see if it's satisfied. Okay, so this is give you 5 and give you 5. Here you go. This is a solution. Okay, the solution, because we can evaluate the log base 8 of 5. We can evaluate. Okay, so that's solution. Let me see. I can give you something else. We can use equivalence property to solve the log. How about this one right here? Or maybe this one. Log base 10 of x squared plus 13 equal to I don't know, we can do this or not, equal to over log base x plus 5. Maybe, I don't know, we can use this. Yeah, let's try to do that. Okay, so we have log base 10 log base 10 of x squared what? X squared plus 13 over log base 10 of x plus 5. Okay, x squared plus 13 over log base 10 of what? X plus 5 equal to alright. Okay. So how we gonna do this? So in order to use log's equivalence property, then you have to have log on both sides, right? And we set up the argument. Over here we have log on the same side, so it means that we need to bring this log over here. So this is mean. So from here we can. Okay, so from here. We can multiply both sides by this log. So I will have this. Multiply both sides by log base 10 of x plus 5 equal to 2 log base 10 of x plus 5. But if you notice, you know, in order to apply the log equivalence property in front of the log, we don't have it. But over here we have number 2. So what you have to do is that you're gonna kick number 2 up here to become exponent. Alright. And now we can, you see that we can set up the argument equal each other. Alright, what kind of equation is that? It's quadratic. Now we can show quadratic. Okay, plus 10x plus 25. So you cancel this. So what you have left is 10x equal to 13 minus 25, which is 12, negative 12. Okay. And x equal to negative 12 over 10, which is negative 6 over 5 as the final answer. And again, you got to go back here and check. Okay. And I don't know that if this one is a solution or not. That is our job. It's your job to go back and check. Okay, but I hope so. I hope this is a solution. Okay, but you can check it easily. It's not really that bad. Just go ahead and plug them in. Okay, but I assume, okay, just assume that this is the answer. Okay, if you go back and you plug it over here and you check and it turned out to be not 2, then this is no solution. Okay. Okay. I'm sorry for the sound in the background. All right. Example 4. How about this one? Let's see if we can do something else. Okay. No, probably not this. How about this one? Okay, how about this one? This is kind of interesting one right here. That's easy, right? But this one you can set up equal to this, so I guess it should be the same. So I'm not gonna go ahead and solve it anymore. I try to find something interesting, you know. Well, let me see. I can find something over here. All right. How about this one? How about the one over here? Log base 10 of 3x squared plus 1. 3x log base 10 of 3x squared plus 1. Minus log base 10 of 3 minus x equal to log base 10 of 3x minus 2. Alright. We're gonna use the property here a little bit. So we have 2 log minus. So if you have 2 log minus, it means you have the log of the numerator divided by denominator. And now you see the base is the same. It's base 10. So we can set up the argument, which is 3x squared plus 1 over 3 minus x equal 3x minus 2. Okay, and this is just a very simple rational equation. So from here I multiply both sides by this denominator. So I have 3x minus 2 times 3 minus x. So 3x plus 1 equal to distributive is 9x minus 3x squared minus 6 plus 2x. So we use 6x squared plus 1 equal to 11x minus 6. Okay. Yep. So from here I can solve for this quadratic minus 11x both sides and add in 6 both sides. So I have a quadratic, and I don't know we can factor this or not. And if we cannot factor it, then we can use a quadratic formula. Let me see if we can factor this. Probably not, huh? Oh yeah, maybe this. 2x, 3x. How about this? Is minus 7. Oh, it should be minus. If it's a minus, then it work. So because over here, look at it, minus. It should be over here. It will be minus 1, right? But the thing that, oh, very close, very close. I mean, I think we can change a little bit to make it better. No. So here, 9 negative 2x squared minus 6 plus 2x, 3x squared minus maybe 6x squared, 9x plus 11x should give you 7. Yeah, I mean, I thought that we can factor, but we cannot. If this one is negative 17, then it's good, or if this one is minus 7, then it's good. But I mean, this is not minus 7. So I think I'm gonna change this a little bit so that it make better. How about if we go ahead and change it to minus? Here you go. Change a little bit. Alright. Change a little bit. Change it to minus. Alright. So the minus here, and oh no, even we change it to minus doesn't work. It must be, hold on, let me see. Okay, this minus here, then which is give you if you yeah, it doesn't work either. Even it's minus, it's not good because this is -6 and 1, yeah, it's supposed to be 8 over here in order to make it work, but it's not working. Yeah, so I guess it's not a so I think I'm just go ahead and keep plus again. It's not make any big difference right here. So I'm gonna call it plus, which is give you +7. But you see that we can it's unfactorable, so we cannot do this. So I have to use quadratic. Okay, use quadratic formula here. Okay, and everybody know how to use quadratic formula already. So I just want you to go ahead and do it yourself. Okay. Alright, so that is how you use log equivalence property. Now the second method of 7 log equation is that you can use the log principle, you know, and property. Actually over here we already use property. You see that in example 4 we already use property. Okay, so let's see how you use the log principle. Log principle, anyone still remember the log principle? What's the log principle? Log principle is that if we have logs b of x equal y, then it's equivalent to x equal b to the y. Okay, and all the log property, of course, you're supposed to memorize. I'm not gonna go ahead and write all the property again here, but this is the log principle. And let's say I can give you something. How about I have something like this? Example number 1, okay? Okay, how about I have this? I have -8, so -8 plus 2 log base 3, 3x plus 5 equal 2. Okay, so in order to use log principle, you see that we have only one log. For the log property, you see that we have both log on both sides. We have 2 log on both sides, but over here we have only one log. So we have for log principle we have to isolate the log. So I mean I need to get the log to the left hand side and remove everything. So I'm going to add on both sides by 8 over here, which is give you 10. Then I divide both sides by 2, which is give you 5. And now you see that this is the base and this is the argument. So the argument equal to the base raised to the y. So the argument here is equal to the base raised to the 5th power, which is pretty big number. So it'll be 81, right? 81 times 3, 243. Then you subtract both sides by 5, minus 5, give you 238. Then you divide both sides by 3, which is not a nice number. Okay, so give you around 79.3. Okay, not a nice number. You can keep it a fraction. Alright, so the main goal when you use log principle is that you have to isolate. You got to isolate the log. Alright, how about this? What if I have let me see, I can use something over here. Okay, how about if we use something here? How about this? How about this one? You know, kind of crazy one right here. But let's see if we can do this or not. I don't know. We can do this, you know. 2 raised to. I think we can. Okay. Let's see we can do this. Okay. Or maybe how about we do this one? This is easy. We already learned how to do that. Let's try to do this. Let's try to have some fun. Okay. Try to have some fun for this one. So I have log base 2 9 minus 2 to the x. So log base 2 9 minus 2 to the x. Okay. Over 3 minus x equal 1. Okay. Alright, let's see how we do this. So we already have one log on the left hand side already, so we need to isolate this. So I'm going to just go ahead and multiply both sides by 3 minus x. So we will have this 3 minus x. So now we can apply the log principle. So we need to kick this up. So you have 9 minus 2 to the x equal to 2 raised to the 3 minus x. Alright, so if you notice, so maybe some of you get stuck right over here. So if you notice, this is subtraction between two exponents. So this one I can write this as this, right? There you go. And 2 to the 8, 2 to the third power is 8. Alright. So what do I have here? So I will have, now I'm going to multiply both sides by 2 to the x. So I have 2 to the x times 9 minus 2x equal 8. So I will have 9 times 2 to the x, distribute them, minus 2 to the x square, right? 2 to the x times 2 to the x is 2 to the x square equal 8. Okay. And this one, I can write it as, I'm going to just go ahead and move it to the other side. So I have 2 to the x square minus 9 times 2 to the x plus 8 equals 0. Alright, so you see that originally we have a log, but now we can bring it to the exponential of equation. And this one, we already talked about how we do this. You know, we can factor. Maybe one of the method of solving exponential equation that we can factor us, because you see that this is quadratic, so we can factor this. Let's see, we can. Okay, so we have 2 to the x, and we're gonna have -1, -8 over here. It is quadratic. Okay, and now see, from log equation then become exponential equation. So I have 2 to the x minus 1 equals 0, or 2 to the x minus 8 equals 0, and this is give you 2 to the x equal 1. Then x equal to 1 will be 2 to the 0, so x equal to 0 as the final answer, and 2 to the x equal 8. 8 is 2 to the third, so x equal 3. Alright, so I have two answers. X equal to 0. Okay. However, x equal 3, when you plug over here, 3 minus 3 0, so undefined. So this is extraneous. Okay, so this is not the solution. Alright. Okay. Kind of interesting, right? I mean, so that's why I say the log function and exponential function is kind of related to each other, because sometimes we use log and we solve the log equation, but during the process it's like we solve exponential equation. All right. So you had to be flexible. Okay. Now example number 3. how about this one? This one I think it's much simpler. We can use some property here. So we have log base 4 x plus 8 plus log base 4 x plus 2 equal to, alright, so you have the sum of the logs, which is give you the log of the product, alright, equal to, and now we can kick them up. So this is equal to this is equivalent to x plus 8 x plus 2 equal 4 to the second power, which is 16, and now you distribute them in, which is give you the quadratic 10x plus 16 equals 16. Cancel them out. So yeah, x squared plus 10x distribute, okay, distribute give you 10x equals 0, and now you see this is quadratic, and now we can factor this. This is kind of a little bit the same as last time, but the last time is a full standard form, a full quadratic form. This is not full. Alright, so you have x equal to 0 or x equal -10. And you plug over here, you see that, okay, 0 work, but -10 not working, right? -10 plus 8 over here, which is -2. So we don't have log of negative. So this is extraneous. Okay. There you go. Okay. Now, how about we do something harder? All of this is kind of easy, to be honest with you. I mean, it's not hard at all. It's very standard, you know, very standard. All right, let's see. We can you can do this. How about I mean, I can do this to use log principle here. Yeah, this is kind of interesting problem. So we have log base 3 and 1 log base 2x minus 7. Okay, let's see, we can do that. Log base 3, 1 plus log base 3. So we have log base 3, 1 plus log base 3, 2x minus 7. Alright, equal 1. Alright, so this is kind of interesting problem here. So we have 2 log, and we gotta recognize, okay, this is the argument. Everything inside this bracket is the argument of the log, and everything inside the parenthesis here will be the argument of this log. Now you have argument here, you have the base, you have the y, so we can kick them up, right? We can apply the log principle to kick this up. So we just give you what? Give you 1 log base 3. Everything inside the bracket, okay? The argument 3 to the first power, which is 3, and I subtract both sides by 1. Just give you 2, and now we see that we can kick them up again. Okay, you can apply the log principle a second time. So you have 2 minus 7 equal 3 to the second power, which is 9. So you have 2 to the x equal to, adding both sides by 7, give you 16. And to the x equal to 16, I can write as 2 to the 4. And x equal 4 as the final one. There you go. So the difference over here is that in this example, you apply the log principle twice, okay, 2 times. All right. Let's see what else. Trying to have some fun over here. Maybe you look at this and you say, "Oh, I don't like to do this," but believe me, it's not really that bad at all. We can do this if you wanna, but maybe some of you don't like it. So I think I'm gonna do something simpler. Let's see. How about this? Okay, let's try to get something like this. Then we change a little bit. Okay, change a little bit, something like that. Okay, let me see I can change it. Example 5. So I have logs base 2, logs base 3 of x plus 1 over 2x plus 3. Okay, equal maybe equal 1. Okay. So we have to log. We're gonna apply the log principle twice again. So I have so I kick them up because everything here is this argument. So I have log base 3 x plus 1 over 2x plus 3. 2 to the first power is 2, and now I apply that one more time. So I have x plus 1 over 2x plus 3. 3 to the second power, which is 9. Alright, so I have rational equation here. So from here I can get x plus 1, 2x plus 3 equal 9. So just go ahead and rewrite it. Multiply both sides by the denominator. So I have this. Alright, so I have x plus 1 equal to 18x plus 27, which is 17x equal to negative 26, and x equal to negative 26 over 17. And hopefully this is the answer, but probably it's not, because you could go back over here and you have to check it. Okay, but I just assume that this is the answer. Okay, I'm not checking for you because the answer is not really it's not a nice number, it's a fraction. But I mean, if you have calculator, you can plug over here and check it. If it turn out to be 1, then that's your final answer. Alright, let me see, I can do something else. Yeah, I think all of them is kind of easy, you know. It's not really that bad at all. I mean, it's easy too. How about this? 2 plus log x and 3 minus log x. 2 plus log x and over 3 minus log x. 2 plus log x over 3 minus log x equal 5. Number 6. 2 plus log x and 3 minus log x equal 5. Okay, I think this is easy. So I just multiply both sides by the denominator, so I have this. Alright, and you distribute the log. Okay, so distribute the log, so you will have 2 plus log x equal 15 minus 5 log x, which is add both sides by 5 log x, will give you 6 log x. If 15 over here minus 2 give you 13. So I divide both sides by log x, so 13 over 6. You know, which let's change a little bit just so that we can make it better. Let's change to 3. Yeah, I think it's 3 is better. Okay, let's change to 3. So 15 minus 3 is 12. There you go, 12 divided by 6. So you have log x equal 2. And x equal to 10. This is base 10, so 10 square, which is 100. There you go. Alright, so the answer is 100. Okay. Let me see, I can give you the last one. If let me see, okay. Okay, so let me see, I can give you something with maybe natural log, because we never touched natural log. Let's see. Okay. Okay. All right. How about this one right here? Okay, example 7. What if I have actually natural log is just a base e, but I think I can do something like this. How about if I have sorry guys, I try to find something something okay, let's just make something simple. Okay. So I have ln x plus ln x minus 3 equal to ln phi x minus 7. So the addition over here to become multiplication. So I have ln x times x minus 3 equal to ln phi x minus 7. And because we are using the second method, actually you can use the equivalent property here and you set this equal to that. But because I use the log principle, so I'm going to go ahead and subtract both sides by ln phi x minus 7. So I have this minus this. Then I set equal to 0. Then you see the ln, the subtraction between ln, which is give you ln of the top. Okay. Over the bottom equal to 0, and now you kick them up, so you will have x minus 3 over phi x minus 7. This is e raised to the 0, e raised to the 0, which is give you 1. So you have this equal to 1, and you multiply both sides by this, so you have x minus 3 equal to phi x minus 7. There you go. So you see that from here actually you can set this equal to each other already. Okay, the argument equal to each other. You don't have to use the log principle. You have to be flexible. Okay, it doesn't have to be log principle or equivalent property all the time. It's up to you as long as you get the final answer. Sure, x squared plus 7 equal to 0. So you have x squared minus ax plus 7 equal to 0. And now you see that you can factor this easily. So x equal to 7 or x equal 1. And you can plug over here and you see that 1 doesn't work. Okay, or maybe okay, let's plug x will be 75, right? And minus 7 is 35. Sorry, 35 minus is 40 something, and 35 minus 7 is 40. 35 is 28. 28, and this is also 28. So this is the answer. Okay, but when you plug 1 over here, 1 minus 3 negative 2. So this is extraneous. There you go. Alright, so I think I'm gonna stop the lecture for log equation over here. It should be simple. Okay, nothing really beyond what we're supposed to learn. So please watch the video carefully and let me know if you have any question. Okay, do not hesitate sending me a message. I'll be trying to answer and reply as fast as I can. I'll see you next time. Bye bye.